Hi kids, now we'll be going into this paper discussion. You can look into the first question. The first question says, two balls of same mass are projected as shown by compressing equally. The springs of different spring constant of K1 and K2. The first ball is projected upwards along a smooth wall and the other rough horizontal floor with coefficient of friction mu. The first ball goes up by distance h, then the distance covered by the second ball will be. So it goes like, yeah, this is the first case. In the first case, you are compressing it and you are leaving it. The potential energy stored in the spring, it is going as potential energy in the gravitational potential energy, they are saying. So potential energy stored in the spring is going as gravitational potential energy. In the second case, potential energy stored in the spring, it is totally going as heat, that is magnitude of work done by friction, mu mg into y. So this is the first case where spring potential energy is going to convert as gravitational potential energy, spring potential energy is going as heat. Now you need to find the relation, like this is the distance traveled along x-axis, so you need to find what is y. You can take the ratio of these two equations and you will end up getting the answer. So these are the only two important equations for the question, right? In the next question, force is given, you need to calculate what is the work done by this force along y equals to x. So force is given, small displacement will be given by this one, work done, small work done will be like dot product of these two, so you will be getting y dx x square dy. Y dx x square dy, you need to integrate this, but there are two variables, they have given like along y equals to x, so instead of y I will be putting x. If y equals to x, dy equals to dx. Now x is varying from 0 to 1 in the question, when you integrate it, you will be getting the required answer. Okay, W1, W2, W3 represent work done in moving a particle in three different paths in gravitational field. So work done by gravity, gravitational force is conservative force, work done by gravity doesn't depend on the path. So whether you take it this way or this way or this way, work done just depends on initial and final point. If initial and final point remain same, then work done by gravity will be remaining same. So all work done will be equal. A wire which passes through a hole is bent in the form of a quarter circle. The wire is fixed vertically on the ground as shown in the figure. The bead is released from near the top of the wire and it slides along without friction. As the bead moves from A to B, the force it applies on the wire is, So let us see what will be the force on the bead. On the bead, here velocity will be 0. Velocity of the bead here will be 0. When it comes here, potential energy will be converted as kinetic energy. So here velocity won't be 0. Anyway, if velocity is 0, net force towards the center must be, it is circular. Whenever you see circular thing, net force towards the center must be equals to mv square by r. So mg minus n equals to mv square by r, but here velocity is 0, so normal will be equals to mg on the bead. But when it comes here, it will be having some velocity. When it is having some velocity in circular path, there must be some force towards the center. So that will be provided by the normal. Normal on the bead equals to mv square by r. So normal on the bead here is outwards, normal on the bead here is inwards. So if they talk about normal on the wire here will be inwards, normal on the wire here will be outwards. So this figure is for bead. So action on the bead and reaction on the wire, they will be exactly opposite, right? A particle is being acted upon one-dimensional conservative force. Position C is in which kind of equilibrium they are talking about. So generally, you know, F is given by minus du by dr, or U dash is minus F, U double dash is minus F dash. So for potential energy to be minimum, for potential energy, I mean U double dash here is negative of F dash is slope of Fx curve. So slope here is negative. If slope here is negative, then this total value is going to become positive. So if U double dash is positive, if U dash is 0 and U double dash is positive, then U is minimum, right? So it is going to be stable equilibrium. The other way of seeing it is, here the net force is 0. If I disturb it slightly this way, then force is negative. The meaning is force will be in this direction, it will try to pull the mass in the backward direction. If I pull it this way, force is in the positive direction, so it will try to go back. So it is stable equilibrium. If you disturb it, then it is going to come back to the same position, so it is stable equilibrium. Okay, if two springs S1 and S2 are stretched by same force, it is found that more work is done on spring 1 than spring 2. So let us see that into equation. So same force, so K1 x1 equals to K2 x2, and they said work done in the first case is greater than work done in the second case. I can write this as K1 x1 into x1. K1 x1 is same as F, right? So K2 x2 into x2 K2 x2 is F, right? So from here I can see x1 is greater than x2. If x1 is greater than x2, then K1 will be less than K2. So statement 2 is correct. Now what about statement 1? If stretched by same amount, work done on S1 will be more than work done on S2. So stretched by same amount, we know K2 is greater than K1. Stretched by same amount in the sense energy in this one is going to be half K2 x square, energy in this one is going to be half K1 x square. Energy in the first guy is more than energy in the second guy. So statement 1 is wrong. A person pushes a box on a rough horizontal platform. He applies a force 200 Newton over a distance of 15 meters. Thereafter he gets progressively tired and his applied force reduces linearly with the distance to 100 Newton. The total distance through which the block has been moved is 30 meters. What is the work done by person during this total movement of the box? Now there are these kind of things you must have seen in kinematics also. When motion is varying, then it's always better to draw the graph. So when you plot f versus x graph, they said like force is constant till 15 meters. After that it is linearly decreasing with the distance till the distance is 30, right? 200 from 200 Newton it is becoming 100 Newton. So that will be the graph. Now fx graph, area under fx graph will be giving us work done. So this part area is 1500, this part area is 750. So total work done will be summation of all this, which will be 5250. The next question, potential energy is given. Then at equilibrium the separation between the molecules and the potential energy are. So equilibrium is force is 0. Force is nothing but negative of u dash, right? Potential energy is given. Force we know is this thing. If force is 0, then differentiation of u must be 0. So differentiate u, put it equals to 0, then you will be getting r power 6 is 2a by b. So r equals to 2a by b whole power 1 by 6. Now when r power 6 is 2b by a, r power 6 is 2b by a. So substitute r power 6 is 2b by a, then you will be getting the potential energy minus a by 2b by a plus b by 2b by a whole square. So when you do the calculation, you will end up with the answer, right? A particle is projected with a velocity v0 along x-axis. A damping force is acting on the particle which is proportional to the square of the distance from the origin. ma is equals to minus alpha x square, the distance at which the particle stops. So if it is stopping, there is change in kinetic energy. So we can go with work done equals to change in kinetic energy. So work done by that force equals to change in kinetic energy magnitude wise. It is going to heat, right? I mean it is going to heat the mechanical energy. So basically its work done will be negative. That is the reason kinetic energy is becoming 0. Anyway, magnitude wise they must be equal. So work done by that force equals to change in kinetic energy magnitude wise. When you do that calculation, you will end up with the something like this. But they said only proportionality, so you can understand from the statement what they mean and from the result what you are getting. M is not there in the result, so you can manage without M, right? You can just assume M is not there and you can mark the answer. A block starts moving up the incline of inclination 30 degrees with initial velocity v0. It comes back to initial position with v0 by 2. The value of coefficient of kinetic friction between the block and the inclined plane is L by 1000, then the closest integer to L. So there are, while it is going up, let me say it is traveling a distance L, this angle is given, so this will be L cos theta, L sin theta. Now while it is going up, and this is like the total motion if I consider. If I consider only while going up, it is traveling a distance of L. If I consider going up and coming down, it is traveling a distance of total 2L. Now in this case, initially there is kinetic energy, finally it is 0. Initially there is some kinetic energy, out of that some will go as heat. How much will be going as heat? That is work done by friction. Work done by friction is mu into n into this distance magnitude wise. So mu into normal is mg cos theta, mu into normal mg cos theta into L. This is the work done by friction magnitude wise. Out of this much initial kinetic energy, this will go as heat, then remaining will go as potential energy mg L sin theta. Now if I consider this case, work done by gravity will be 0. Initially there was some kinetic energy, finally there is some kinetic energy, but some of it is going as heat, right? So out of initial kinetic energy, some will go as heat. How much will be going as heat? Work done by friction magnitude wise. Mu mg cos theta into this distance plus this distance, which is 2L. Out of this much initial kinetic energy, this much will go as heat, remaining will be final kinetic energy. This is the equation while going up, this is the equation when you consider the total motion. Now I have taken this equation, I have brought it to the right hand side. I have taken this equation, I have brought it to the right hand side, and I have brought it this to the left hand side. Thereafter I have taken the ratio of them and I solved for mu. Tan theta value is known, so substitute it, get the answer. Two blocks of masses m and 2m are connected. Two blocks of masses m and 2m are connected to a light spring of spring constant K that has one end fixed as shown. The horizontal surface and pulley are frictionless. The blocks are released from when the spring is not deformed. The string is light. So maximum extension in the spring. Now what will happen when you leave it? This block will be going down. When this block goes down, this block will be moving ahead. So this will be going down, this will be going this way. Now you know they are connected by a string. So if this moves down by distance x, this one will be moving forward by distance x. So the spring will be expanding by x. So if it moves by a distance y, see maximum extension in the sense its kinetic energy is going to be 0. It is going to accelerate, gain some kinetic energy. After that it will start deaccelerating and it will become 0. So that's the maximum extension. Let me call that maximum extension as capital Y. Then drop in gravitational potential energy is 2mgy. This mass is 2m. So drop in gravitational potential energy is mgh. 2m into g into y. Where is that drop in potential energy going? This is neither gaining kinetic energy, this is neither gaining kinetic energy, because at the maximum extension kinetic energy is 0. So whatever drop in gravitational potential energy, it will be going as increment in potential energy of the spring, half k into y square. If this goes down by y, this one will expand by y. So maximum extension is going to be 4mg by k. Now in the next question they are asking at equilibrium position. At equilibrium position in the sense, this tension will be how much? This tension will be equals to, if this is in equilibrium, this one will be in equilibrium. If this, because these two accelerations must be same, right? They are connected by the string. Magnitude wise their acceleration must be same. So if this guy is not accelerating, this guy also won't be accelerating. So here tension is going to be 2mg. If tension is 2mg, then spring force must also be 2mg, because net force on this guy also must be 0. If the net force on this guy is 0, 2mg will be balanced by tension. So tension equals to 2mg. If tension equals to 2mg, then spring force is 2mg. Spring force is 2mg, k into y equals to 2mg. So y equals to 2mg by k. Y equals to 2mg by k. So at equilibrium position, it will be only half of this displacement. I mean, if you have studied, if you have a basic idea of SHM, you will be understanding that it will be oscillating like 2mg by k. This will be the equilibrium position. So 2mg by k, 2mg by k. Amplitude will be 2mg by k, and the extreme position will be at 4mg by k from here. Anyway, so they are asking at the equilibrium position. At the equilibrium position, what is the displacement it went down? It is 2mg by k. So drop in gravitational potential energy, 2mg into y, like mg into h, that mass is 2m. Drop in gravitational potential energy, it will be going as spring potential energy plus kinetic energy of this guy plus this guy together. Right, now apart from that, we understood that y will be 2mg by k. You just substitute it back, then you will be getting maximum kinetic energy is, for maximum kinetic energy, potential energy has to be minimum, or I can say maximum kinetic energy, maximum velocity in the sense first differentiation must be 0, acceleration must be 0, or maximum kinetic energy, minimum potential energy in the sense first differentiation must be 0, that is force is 0. The other way of seeing it is, it will be accelerating till some point, after that it will be deaccelerating. You need to see where is that point of maximum velocity, whatever. So maximum kinetic energy will be this thing, and minimum potential energy, this is minimum potential energy, right? This is not matching with option D. Drop in minimum potential energy in the, when the kinetic energy is maximum, energy stored in the spring is. So when kinetic energy is maximum, this is the energy stored in the spring. This is not matching with option D. Maximum kinetic energy is fine. Then they are asking some other thing. Maximum energy stored in the spring is 4 times that of maximum kinetic energy of the system. Now maximum energy stored in the spring will be depending on like maximum extension in the spring. Maximum extension in the spring is this much. So maximum energy stored in the spring will be half k into that displacement square, that extension square. So when you modify it, you will be getting this thing you can write it as 4 into 2 times of this, whatever. So this, what is this? This is the maximum kinetic energy, right? So maximum potential energy in the spring is 4 times of maximum kinetic energy of the system, right? Yes. The next question, the options were printed wrong, so we will see like what will be the answer for the right options. They are talking about which is conservative force. So the first force is this. So you will be calculating what is the work done, and you will be small work done, and you will be integrating. So r cube dr integration will be coming into picture. So r power 4 by 4. Now you can clearly see it depends only on the position, initial and final position. So that's a conservative force. The next one also, you will be doing small work done and you will be integrating. When you do that, you will be getting log, and it depends only on initial and final position. Now the third one, I can see something. So I have written the same equation like this. Now if I call this as position vector by its magnitude will be unit vector, and this is position vector square. So I can put it as r square. Now again, this looks very similar to the previous question. Again, I can do the work done, I can integrate it, and I can see it depends only on the position. So this is also conservative force. But if I can't see this format, then what I should be doing is, I always have this thing, right? If the force is of the form fx I cap plus fy j cap plus fz k cap, then if this determinant is 0, then it is conservative force. If this determinant is not 0, then it is non-conservative force. You can always put this there and you can cross check, it will turn out to be 0. Now the next case, this is the force. Now this I can't see properly like that, so I am going by the other way, but instead of that we always have this. This you try by yourself. You can substitute, they have given fx and fy. So you can substitute fx and fy and you can see whether it is conservative or not. It will turn out to be non-conservative. What I am doing is, I have taken 3 paths here. One is this path, one is this path, one is this path. I am trying to see what is the work done in all those 3 paths. If they are equal, I mean, I can't really say like if they are equal it will be conservative force, but if they are unequal I can say like they won't be conservative, it won't be conservative force. So I am calculating what is the small work done. It turned out to be this thing. Now if I integrate, I will be getting the total work done. So what I am doing is, I am calculating this work done along this path. Along this path, first term is going to be y coordinate is going to be 0 for this entire thing. So first term is going to be 0. Second term, change in y coordinate is 0, change in y coordinate is 0. So second term is also going to be 0. So work done in this path is 0. Now when I calculate work done in this path x is not changing. So dx is 0. Now what about this thing? X value is a square, and dy by this thing. Now you need to integrate from 0 to a. Y value is varying from 0 to a. Anyway, I didn't do the integration, just keep it there. Now if I calculate what is the work done from here to here, x value is 0, and dx value is 0. X is not changing. So dx is 0 and x value is 0. So both terms are going to be 0. Now when I go from here to here, it is y is not changing. So dy will be 0. But what about this? Y value is a. Y value is a. Instead of y, you can put a and you can integrate. Now these two are looking same. So I didn't do any integration. Now I am seeing what will happen along y equals to x line. When I do along y equals to x line, these two terms will be same. So I just substituted instead of yx and I calculated what is this. It turned out to be this thing. For some reason I think I can see like this integration and this integration won't be matching. So I kind of understood it is not conservative force, but that's not the better way. The better option is always checking whether this determinant is equals to 0 or not equals to 0, right? In the next case they are asking, it is moving in circular path and the minimum coefficient of friction so that the 4m doesn't move. Work done by gravitational force on the block m is positive when it moves from A to B. When it moves from A to B, it is going vertically downwards. So work done by gravity is positive. Yes. Power developed by tension is 0. Tension is always perpendicular to the velocity. So power is always 0 by tension. Kinetic energy of m in position B equals work done by gravitational force. Now how many forces are acting on this? There are 2 forces acting on this, gravitational force and tension. Now tension is not doing any work. So whatever kinetic energy increment is happening, that must be because of work done by gravity. The kinetic energy of m in position B equals work done by gravitational force on the block when it moves from position A to B. Yes, that's correct. Work done by gravity is going as kinetic energy. Now we will look at option A. Now if the friction must not make it move, so we need to see like for what maximum tension, where maximum tension will be happening. So if this doesn't move when the tension is maximum, then it won't move in all the other cases. Now tension will be maximum when this is at the lowest point. This you must be knowing. Even if you don't know, you can predict like here T will be balancing this mg's component, and when you go here mg component is increasing. Apart from that, velocity is also coming into picture. So T minus mg equals to mv square by r. Tension will be maximum at the bottommost point of the circular motion. So we will look at concentrate on the bottommost point of the circular motion. Now this length is L, so this component is going to be L by 2. This total length is L. If this is L by 2, this will be L by 2. So drop in gravitational potential energy is mg L by 2. Drop in gravitational potential energy is mg L by 2. That will be going as kinetic energy. From there we will be getting what is the velocity at the bottommost point. Now if I want to find tension, T minus mg net force towards the center, that must be equals to mv square by r. mv square by r. Now mv square we got from here, you just substitute it, then you will be getting mv square by L as mg. V you got from here, right? You just substitute V, then you will be getting mg. So tension equals to 2 mg. For this tension, if this is not moving, for any tension it won't be moving. So for that tension, under the critical case, if it is matching with maximum friction, mu into normal, normal is 4 mg. So mu value will be half. So option A is correct. Next question, potential energy is given. Initial coordinates are given at time t equals to 0. They are asking the particle is having constant acceleration. Is that true? If you know potential energy, if you want to find the force, then you will be using this equation, and you can see force is this much and mass is 1 kg. So acceleration will be the same thing, and it is constant acceleration but not zero acceleration. So option A is correct, option B is wrong. Now they are asking the speed of the particle when it crosses y axis. When it crosses y axis, in the sense x coordinate must be 0 when it crosses y axis. So it will be going along this path. So when it crosses here, now the distance travel along x axis is how much? 6. The distance travel along x axis is 6. So from there you can get what is the time taken from here to here by considering the motion along x axis. Half a t square along x axis equals to 6. So t equals to 2. After 2 seconds it will be here. After 2 seconds its velocity is going to be v equals to u plus at, that is 6. After 2 seconds its velocity in the vertical direction is going to be v equals to u plus at, that is 8. So then velocity is going to be 10. Now apart from that they are asking some other question. Coordinates of particle at t equals to 1. So in 1 second how much distance it will travel along x axis? Half a t square, that is 1.5. Along y axis half a t square, that is 2. So from here it is traveling 1.5 along x axis and 2 along y axis. So if it moves 1.5, then its x coordinate will be 4.5. If it moves down by 2, then its y coordinate is going to be 2. That's also correct. The spring constant of spring A is twice the spring constant of spring B. Each spring is cut into 2 pieces. First piece of spring is 4 by 5 times of its rotor length. Second piece of spring is 5 by 6 times of its rotor length. Both springs of equal length initially. So they are of equal length initially. Yeah, before that you must be knowing this. Spring constant is inversely proportional to length, and this information is given in the question initially, and they said both are of same lengths. So if spring constant is inversely proportional to length, I can say k into L is constant. K into L is constant. So first spring constant, for the first spring, this is for the first spring, this is for the second spring, and they said they are cutting into 2 parts. The first part is having length 4L by 5, second part will be having length 4L by L by 5. First part is having, second part is having 5L by 6, they said, so first part will be having L by 6. Now k into L is constant. These lengths are same for A and B, they said. So if this is becoming 4L by 5, this is going to become 5K by 4. So from there I can say like new spring constant of that this length is going to be 5 by 4. Now if this is going to become L by 5, this is going to become 5 times. So new spring constant is 5. Similarly L by 6, this will be 6. 5L by 6, 6 by 5. So you can see like this is the spring constant of first part of spring 1, spring constant of second part of spring 1, first part of spring B, second part of spring B. Now they are asking to take the ratio of this, that is first part of spring B by first part of spring A. Kb by Ka value we already know, that's given in the question, you just get the answer. Now similarly they are asking the ratio of this guy and this guy, second part of spring 1 and first part of spring 2. When you take the ratio, you will be getting the answer, right? A ball leaves the track at B, which is at 3 meter height from the bottom. The ball further rises up to 4 meter height from the bottommost point. From here it is rising till 4 meters. So from here it will be rising 1 meter. So you need to, this angle, they said it is leaving at an angle 30 degrees. So they are asking to find what is this h. So it will be coming here, potential energy will be converting as kinetic energy will be converting as potential energy, still some kinetic energy is left, it is leaving at an angle 30. So you know it will be undergoing projectile motion. If the velocity here is v, then horizontal component will be v root 3 by 2, vertical component will be v by 2, horizontal component will be remaining same. And this total length from here to here is 4 meter, this is 3 meter, so this will be 1 meter. Then you can use kinematics like for maximum height v square by 2g, vy square by 2g. From there you will be getting what is the velocity v. Or if you want to get by the other way, you can always use energy conservation between these 2 points. Kinetic energy is going as potential energy plus kinetic energy there. Whatever it is, you will be getting the same answer. So you know v square here. Now I can apply energy conservation between these 2 points. Initial kinetic energy is going as potential energy plus kinetic energy here. Initial potential energy is going as potential energy at the final point plus kinetic energy at the final point, half m into v square at the final point, v square is 8g. Then you will end up with h equals to 7. So basically when you leave it h equals to 7, it is going to travel this height of 4. Still it has some kinetic energy, right? Displacement versus time thing is given. What is the work done in first 6 seconds? So I can go with work done. Instead of work done, I can go with change in kinetic energy, because work done equals to change in kinetic energy. So this thing is given, I can modify it. From here I can differentiate and get the velocity. At t equals to 0, velocity is minus 6. At t equals to 6, velocity is 6. So velocity is changing its direction, but magnitude wise it is remaining same. So change in kinetic energy is 0, so work done will be 0. In the next case, there are 2 blocks like this. Now first one is obviously going with more speed, second one is going with less speed. On the first block, the friction will try to pull it backwards. On the second block, friction will try to push it forward. So what will happen, this guy's A guy's speed is 8, B guy's speed is 4. Now friction will try to reduce the speed and increase the speed. Now once they reach common velocity, what will happen, friction will disappear. After that there won't be work done by friction. So they will be achieving common velocity. So instead of going by lengthy way, you can always go by conservation of momentum. These are the initial speeds. Finally they will be moving the common speed, and friction is going to be if I consider this entire thing as my system, friction is going to be internal force. So I can conserve momentum in the horizontal direction, right? I can conserve momentum. So initial momentum is 8 into 1 8, 3 into 4 12, 8 plus 12 20. Initial momentum is 20, final momentum is 3 plus 1 4, 4 into v. So v equals to 5. So once I know v equals to 5, I can calculate what is the kinetic energy of this guy, half into m into v square 32. Kinetic energy of this guy is 24. So initial kinetic energy is this plus this, which is 56. Final kinetic energy is half into, this is looking like single block moving with speed 5. So half into m into v square, final kinetic energy is 50. Initial kinetic energy is 56, final kinetic energy is 50. Where does the remaining 6 went? It gone as heat, because work is done by non-conservative force, friction. In the next case, a small ball is projected and it is going like this, it is going like this. After this, it will be following projectile motion and it is going to hit the same point. For what value of v that will happen, they are asking. So it is going like this, it is going like this, and after, sorry, take this as u, okay, this is v, this is u. So after this, it will be following projectile motion. Now if it is following projectile motion, what is the time taken for it to hit? This is only horizontal velocity, so I can calculate time taken using the vertical component, square root of 2h by g. This length is 40 meters. So the time taken for this projectile is this much, square root of 2h by g. In that time, what is the distance travel along x-axis? This is 60 given. So distance travel along x-axis will be velocity in the horizontal direction, take it as u into time taken. Time taken is 20 by 7. Velocity along horizontal direction into time taken will be giving you displacement along horizontal direction, because acceleration is 0. From there you will be getting the velocity here as 21. Once you get the velocity here as 21, I can do energy conservation between this point and this point. From here to here, no, in this entire thing, energy conservation, mechanical energy conservation is valid because friction is not there. So I can do energy conservation from here to here. So initial kinetic energy is going as kinetic energy there, that is half m into velocity square there, 21 square. Initial kinetic energy is going as kinetic energy here plus potential energy there, potential energy mg into 40. So initial kinetic energy is going as kinetic energy of this guy plus potential energy of that guy. Now the only variable is v. When you solve for v, you will be getting the answer, right? A particle is projected along the inner surface of smooth vertical circle of radius r if its velocity at the bottommost point is something. If the particle leaves the circle at an angular distance from the highest point, then the value of x. So they have given some velocity here and they are saying like it is going to leave the circular motion here and it is going to perform projectile motion from here, where this angle is theta with the vertical they said. So here the velocity is v, I just assume, I mean it will be in this direction. So there will be mg's component will be mg cos theta, mg sin theta. Apart from mg there will be normal also. So when something is performing circular motion, I can always write normal plus mg cos theta equals to mv square by r. Now when it is leaving contact, that normal is going to become 0. Now apart from that, I can do energy conservation from this point to this point. Here if I take the reference as potential energy is 0, then here potential energy will be, this length is r and this length is r cos theta. So potential energy will be mgr plus mgr cos theta. Kinetic energy is half mv square. Initial kinetic energy is given in the question, so I can say this total energy must be same as this total energy. I can do mechanical energy conservation. Apart from that, I need to write circular motion constant. I am going to rewrite the same thing here. This is what I will be getting by mechanical energy conservation. This is what I will be getting by circular motion constant. Here there are two variables, cos theta and v square. I need to solve for them. So what I am doing is, instead of half mv square, I can get half mv square from here. Half mv square from here will be half mgr cos theta. So instead of half mv square, I will be putting half mgr cos theta. Instead of half mv square, I am putting half mgr cos theta and I am solving for cos theta. I am getting it as 3 by 5. Right? Thank you.